In this video, we are going to do the gear arm. Let me pull up the dimension sheet. So the gear arm is probably the most complicated part that we do the entire semester. We have a lot going on. If we look at it, we have a ton of lines and curves. And to go from one curve to another curve to another curve, it's not easy. There's a very specific way you have to do it, or else you'll end up not having those smooth transitions like we see here. And the way we're going to get those smooth transitions is by doing constraints. And we've touched on constraints this semester. Actually, you've done a bunch of constraints without even knowing it. But today we're really going to dive into what constraints mean on a deeper level. In addition, we have this weird like jelly bean looking shape over there. We've got to figure out how to do that. So without further ado, let's switch over to Inventor. And before we draw the part, I just want to have a quick little demo on what constraints are. And I said before that you've done them before without even knowing it. Here's what I mean. When you drew a line and you did a straight line, that little constraint that comes up right here in that little space where our mouse is, that is showing, okay, this is going to be a 0-degree angle. If you do 90 degrees to that angle, that little perpendicular constraint appears, saying that those two lines are going to be 90 degrees from each other. You can't change it, right? I can't move this angle up or down. I have to move everything because it's locked at a perpendicular line. If I just did an unconstrained line, I 100% can move it any way I want because it's not locked. And if you take that line, you can, well, let me just start by saying the constraints are located over here. And different constraints are parallel constraint. If you have two lines, you can say parallel constraint, line 1, line 2, boom. Now those lines are parallel. They are constrained that way. Let me Control Z it to get rid of it. You can also click a line and say, I want to add, a vertical or horizontal constraint, right? I'll do that for the one and then the other right there. So now it's going to lock it at a vertical or horizontal line. You can also do a tangent constraint. Tangent, for those that took pre-calc or calc, you know that it's a line intersecting a circle at one location. So if you have a line and a circle, a tangent constraint, line 1, line 2, boom. It'll marry it so it's only touching in one location. You can also have a symmetric constraint if you had something that you were mirroring it over. And there's a bunch of different constraints you can have. Now that we have that background, I think we can begin the part. I would recommend having the part up on your phone or on a different screen. It makes it easier to see what I'm doing and not just seeing the part be drawn, but rather look at the cut sheet and see why I'm doing it. So I'm going to start in that little middle area over here. I'm going to make this point right here my origin. And we're going to start by drawing like this base right here. So not the little stuff going on in the middle, but the outside line. So I'm going to do a circle right here. And with this part, we do have to do a little bit of either math or just some like common sense. Because when we do a circle, notice how Inventor wants you to type in the diameter. However, because the cut sheet, the dimension sheet, has a bunch of curves, it only tells you the radius. So in order to be able to figure what the diameter is, you're going to have to multiply things by 2. And if you don't want to multiply it by 2, remember that where you type in the dimension is also a calculator. So, for example, this circle right here has a radius of 1 3/8. If I want to make that a diameter, I could just make that 2 6/8. If that doesn't jump out to you, I could say 2 times, parentheses, 1 plus 3/8. And what that's saying is the 1 plus 3/8 is 1.375, which is the radius, and then multiplying that by 2. And 2 6/8 would be 2.75. Just showing you different ways of doing it. Okay. And then over here on the left, we have a slot command, a center to center slot command. And we're going to put it right on the x-axis. The center to center distance appears to be 1. And the height is, another one, right? The radius is 7/8. So what does that make the diameter? Well, you got to double the numerator, right? So either 14/8 or 2 times 7/8. 14/8. Okay, coming over to the right-hand side, we have that weird jelly bean shape. And it's actually really simple to do that jelly bean shape. If you do this drop down over here, there's actually one called center point arc, slot center point arc, which allows you to create a slot that is on a curve. So the way to do that is you look at what it's saying, select the center of the arc. Well, it's going to share the same origin, right? That's the way I did it. Okay, select the start point of the arc. Okay, so what's that distance? 2 space 5/16. Enter. And what angle are we going at? Okay, I see 40 degrees. And finally, what's the diameter? Well, we have a radius of 7/8, which we now know is 2 times that. So 2 times 7 divided by 8 will give me the diameter. Okay. We also can add a dimension to say that the distance from this point to this point is 5 13/16. So I'm going to do that now. Point A is right here. Point B is, gotta make sure you click it correct. This point right there. And that will be 5 space 13/16. And we want to kind of make sure that like the right thing is moving. Like when we select that, either this could be moving to the left or this moves to the right. And sometimes Inventor will predict it correctly. Other times it won't. Hopefully we have an instance where it does not predict it correctly, so I can kind of show you some possible troubleshooting methods. Perfect. So, a great example. So, did it work? Kind of. Well, no, it didn't work. But it didn't disobey me, right? That distance is now 5 13/16, but that's not what I wanted it to do. I wanted this to move to the left. So we could fix that by doing a few different things, right? I can try and put like a constraint right here. And let's try it again. And if it works, then I will redo it to show you a little bit more slowly. Perfect. Okay, so let's go back. So what I did was I added a vertical constraint, meaning that this cannot move up or down vertically. And I went vertical constraint, and then I selected this point right here, and then the origin right there. Now it's locked in this direction. So because this can't move, the only thing that's free to move is the lines that are green, which is this. So when I go ahead and change that dimension to 5 13/16, only this can move to satisfy that command. And notice we are good. Okay, what else? Okay, I see a little circle in this area. And when you're doing this, try to avoid where the dashes appear. Sometimes it'll actually add a constraint where you don't want one, and then it'll mess it up. So it's good to do it when you can get it not on something. And the diameter of this is 1 space 5/8. This one is a diameter, so you do not have to double it. And we know that this is located, we can do some dimensions. Point A to to here. That is 0.75 or 3/4 from there. And then from here to the origin is 1 space 7/8. Okay, and we're going to be trimming out the unnecessary parts. So now here's where it gets a little bit tricky, or a little bit new at least. We have these curves, right? Curve, and over here it's actually more of a straight line. And the way that we're going to do the curve is we're going to add the circle, then we're going to add the tangent constraints, and then we're going to trim off the excess. So you kind of want to put the circle somewhat in the vicinity of where it needs to be, and then we will do the tangent constraints to finally put it in the proper location. So right here, I'm going to put a circle, and it says radius is 5/8, so we're going to put 10/8. Same with over here. Looks like another 10/8. Over here, we have a 1 3/4 radius, which is 2 6/8, or 2 times 1 3/4. And over here, it's actually not a curve. It's actually going to be a straight line. So when you do the straight line, you're just going to want to make it really long. And I'll show you why by making it kind of short and hoping that it works. Okay, now that we place the geometry there, look at that smorgasbord. We got to add some constraints. So the tangent constraint is over here. And what the tangent constraint does is it takes two lines and has them, places them so that they would only intersect in one location. So I'm going to do constrain. And I'm going to have these two go. So line 1, click, line 2, boom. And it moves it. I'm going to do it again. Line 1, line 2, boom. And now it perfectly kind of gives you that right smooth transition. Line 1, line 2, boom. Does it matter which one you do first? I actually don't remember. I typically do, let's try it, right? I guess not always. I typically try to click the line that is already in its proper location first. I don't know if that actually matters. So I'm going to click line 1, line 2, boom. Which one is it? Is it actually going to this line? I think it's this one. Line 1, line 2. Yeah, it looks good. And then this one, being only a line, it's actually no different. You're going to click line 1, line 2, and then line 1 and line... See, it won't even let me click this line, so it has to be this one. And now here's what I was saying before with, like, you got to make the line long enough. This doesn't connect that line, right? So if you ever run to that case, you can actually do an extend. An extend will project it until it does hit the part. Okay, I think we're done for now. Am I missing any dimensions? I could add, there are two that I could be adding, but that doesn't mean that the part isn't necessarily drawn correct. I think it is. Okay, so let's let's trim away some of the lines that we don't need. And this is where you gotta be a little bit careful. You don't wanna miss anything or else it might not work when you extrude it. So I'm gonna trim off this area. This black line right there is just a dimension. It's the blue or the green lines that you're following. So go trim happy. Might have to zoom in on some of the areas to make sure you don't miss anything. Like that right there is a commonly missed place. I think that's good. Okay, let's finish that sketch and extrude it and hope that it works. Yes, okay. And we're going to extrude that 0.75. Okay, so now it kind of looks like a, I don't know, like a weird guitar. Nah, not really. I don't know what it looks like, but it's all right. So we'll do another sketch, and we're going to do it right on top of it. Let's get that in the orientation. Yeah, let's get that way. And actually, the next two sketches are going to be pretty easy because we already have a lot of our geometry drawn. So we're going to add the second layer, which is a lot of the same stuff again. So I'm going to do a circle right at the origin. And this is going to be a diameter of 1 3/4. So 1.75, or you can do 1 space 3 divided by 4. You're going to do another circle over here. And I don't want to like have to locate the dimensions again. So if you kind of hover over like the arc right here, the center of this arc will occur. And then you can just easily click on it. And now it's a lot easier. And you can actually just like drag it out to the end to get the 1 5/8 again. You don't have to type it in. You can just drag it out, click, boom. We got to do another slot. So remember the directions, the center of the slot, center of one of the ends of it. So you got to hover, and then once you hover, the little black dot appears, click, and then you can type in 40, or you can go to hover, click on that black dot, and that's 40 as well, and then drag it out to the end, or type in 1.75, right? Because that'd be 14/8, yes. And then finally, a traditional center-to-center slot, same thing, hover over this arc and get that black dot to appear, go over one, and then, oh, I did not make that straight, so let's do it again. 1, and then the 1.75. Escape out, and we're gonna now extrude it. You might have to click on all 4, and this distance is 0.5. We're gonna now essentially do the same sketch again, only make it a hole going in the other direction. So we're gonna do another 2D sketch right on any of these 4 surfaces. I'm gonna make it the way I like to see it, and we're gonna just do it again, just with the hole dimensions. So this hole right here is, and now here is where we see something different, right? We see 1.123 and 1.125 ream. And what this is talking about, guys, it's what's called tolerances. And tolerances is telling the machine shop or the manufacturer the range of dimensions that this dimension could be. So that's saying that this dimension right here, this hole, can be as low as 1.123 and as high as 1.125. So for dimensioning it in Inventor, you can kind of do any of those numbers. I'm going to do the 1.125 just because it's a nice whole number, 1.125. Same with this up here, hover over the arc, get the black dot to appear, and this one is 0.75. The slot, hover over the arc, get the black dot, 1, and then you can hover over this arc to get this black dot, and then 7/16. That looks small, something's wrong. Yep, okay. That's not 7/16, that's radius 7/16, meaning it's double that, so 14/16. Okay, so let's get that again. 14/16. And then the curved jelly bean shape. Center, remember, follow the directions in the bottom left. Uh, 14/16. Finish that sketch, extrude, 1, 2, 3, 4 in the other direction, and all. And the last thing I'm going to do is, it says that the material is cast iron, so I'm going to make a cast iron, and that's it. We can save that up. We can call this the gear arm, and in the next video we will put it on the drawing sheet.